Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering, Edra, Ichalgarji, District Kolhapur, Maharashtra. As we had gone through a group technology in a previous video, where we have gone through some points that why group technology is needed, what is group technology, and what kind of parts are familiarized according to the size and geometry and all. So we have gone through grouping part families. So while methods of grouping parts in some families, there are some methods to visualize methods to differentiate the parts of that families. So we had gone through some of the methods that visual inspection, parts classification and coding, and product flow analysis. If we see, visual inspection is as we have visually we can sort out all these part families. Where in composite part method, as briefly have explained before uh, previous videos. Here in this method, a hypothetical composite part is formed on the basis of the future of all the components forming such group in future, or questioning about that. If you see in this figure the number of components manufactured in a lathe, the various operations include setting the length, facing, turning, facing, turning, grooving, drilling, boring, reaming, counter boring, chamfering. So many are there, etc. So each job may not need all the operations, isn't it? An imaginary component is composed with which involves all the operations needed for the group. The tool setting is done for such component on a multi-tool setup, say a turret, which can easily handle up to 11 tools, isn't it? Depending on the particular component to be worked on, instructions are prepared to indicate the tools and the sequence in which they are to be used. Whenever a new component is to be made, its group is determined and then its sequence of operations and tooling is prepared. This is what about that composite part method. So this is what very important that we have discussed in a previous class, that we have said that next video will see about this. In this part classification coding, and in this method the parts are grouped into families by uh, considering the individual design or manufacturing attributes of each part. The attributes of the parts are uniquely identified by means of a code number. This classification and coding may be carried out on the entire list of parts of family. The many systems have been developed throughout the world, but none has been universally adopted. One of the reason for this is that a classification and coding system should be custom engineered for a given company or industry. One system may be best for one company, while a different system may be more suitable to another company or industry, isn't it? So if you see some types of parts of classification and coding system, this is what two categories of part similarity can be distinguished, that is design attributes and manufacturing attributes, and another is design and automobile. And this is the reasons uh, for using classification and coding system where we have used. If you see, if you see here, classification and coding system, as we have discussed in previous video, that a system based on the part design attributes and part manufacturing attributes, even both of combined both design and manufacturing attributes. And if you're talking about coding system, the three basic coding structures that we have discussed, first is that chain type structure. This is also called that polycode, as we had discussed in previous videos. And we have discussed even hierarchical structures, also called as monocode. So in this hierarchical structure, the interpolation of each succeeding symbol depends on the value of the preceding symbols. The hierarchical structure is also called that monocode. This provides a relatively compact structure which convey a lot of information about the part in a limited number of digits. The first digits, that is 0 to 9, we'll see what exactly that is 0 to 9, that divides the part into major groups such as machined part, cast parts, forged parts, etc. And the second digit may be subdivided the machine parts into rotational and non-rotational parts, and the third and subsequent digit may partition the machines into subgroups. If you see, as you can see here, that is coding system is that digit 1 part classes. This is what part classes 0 to 9. This is digit 2, that main shape. Digit 3 rotational machines, that internal shape element rotational and main bore and rotational element. And digit 4, digit 5 and 6 is dimensions, 7 is material, and 8 is original shape of raw materials, and this ninth is accuracy. This is what the coding has been there. So if we gone through this chain type structure, this is what kind of chain type structure, where one is material, as we have seen in that chart. We'll see the chart. And before that, what is importance of this coding is very important to see. The important classification and coding system, there are several classification coding system. Here are some important systems are listed here. So one is bridge system, that is bridge burn system, code, that manufacturing and data science, and that cut plane, DCLASS, Optis method, multi-class, para analog system, mic class system or MICLASS class system, Toshiba, assembly part code, SAGT, PGM, para, and LITMO. LITMO. these are the some important classification of some important systems are listed in coding system, where the optis part classification system is very uh, maximum where we used. So we'll see one example of that optis method. So this is optis part coding system. This is one a given example has been given. So so uh, if you see one example of this part coding system, how it would be. So here, given a rotational part design below, determine the form code in optis part classification and coding systems. This is one a part where this is half 13 UNC, that is in unfired coarse pitch threads. Half is the major diameter of this and 13 threads per inch, and this is the diameter, and here is up to here, this is the dimensions, and here is up to here the dimension, step per hour dimension, and from job dimension is 1.5, and this is throughout the hole is there, and that is 0.250, and this is the end dimension is 0.750. This is what a given. If you want to coding for this, if you say take a solution, length to be diameter ratio is L of D, that is 1.5. As I have told this is first digits, the where it lies is 0 1 2 3, you have to be check it out, and where it lies L and D, or it should be less or equal to zero point 0.5, so you have to put just 0, or it is lie between 0.5 to 3, so you have to put 1. So it would be like that. So that is 1, and digit is 1, from it, it is digit 1, that is lies between 1.5, so it comes a digit 1, isn't it? So next, external shape, both ends are both ends are stepped with screw threads, one on one end, isn't it? External shape, what is that? Both ends stepped, this side also stepped with screw threads at one end. So digit 2 is 5. So digit 2 is main step. What is that? External shape element, and this is main shape, and this is main. If you see, this is a special case where both sides stepped, isn't it? So here, that is both sides are stepped, there will not be, you can't be see here external shape, main shape, like that. If you see here, with deviation, so fifth is a special case. So the rotation is there, the fifth is in rotation part, and that is a special case of two sides are step. So second digit is of 5, you can say his second digit is 5. And third is what? Internal shape, that part containing a through hole. So digit 3 is 1. So digit the rotation, that is 1, the internal shape element through hole, isn't it? This is rotational, this is main bore or rotational machining. This is not rotational, that is internal shape element, isn't it? So that would be a 1, or you can say this no shape element over there directly through the hole. So element is, sorry, third digit is no shape element, where internal shape, if it is a inside is thread, so automatically the code will be digit will be 2. The functional groove is, if it is there, the code is 3. Now here in this job, throughout hole is there, so no any disturbance, that is plain through hole. So as we see digit 3, shape, no shape element inside, internal shape, isn't it? Third, rotational machining internal shape. That is what these three includes, where one is, we can say, one is for no shape element inside the internal shape of that material. So digit 3 is 1. If you say plane surface machining, none. Plane surface machining have not done or not mentioned over here. So digit 4 is 0. So auxiliary hole, gear teeth, etc., none. And digit 4 is plane surface, no surface machined, as I have not figure machined in this figure. The surface finishes symbol is not given, so none. So even next is auxiliary holes or gear teeth. Digit 5 is also not has been given, that is digit 5 is auxiliary holes and gear teeth has not mentioned, so automatically no auxiliary holes and so automatically fifth is also 0. So as we have gone through this figure, first digit is of length and diameter ratio, that is 1.5 is 1. Second digit is 5. Third digit is 1. Fourth digit is 0. Five digit is again 0. If you see this coding, the code is optimized system is 15100. 15100. This is what the optis part coding system. Likewise, we have to code this kind of use this kind of system. And now this is what actually this is fourth type of method, where mm, as we have gone through only three types of methods, uh, and this is what one production flow analysis, the part classification and coding. This is also one method of grouping parts into families, and this is one is a kind last method of grouping, that is production flow analysis. The production flow analysis is a method for identifying part families and associated machine grouping that uses the information containing on process plans rather than on part drawing. That is would be very process plan, concentrated on process plan, not on that part drawing. Work part with identical or similar process plans are classified into part families. These families can be then these families can then be used to form logical machine cells in group technology layout. And the procedure in the production flow analysis must begin by defining the scope of study, which means deciding on the population of parts to be analyzed. That is in this method makes use of information containing one on root sheets rather than that on part drawing, and work part with identical or similar, as we said here. There are some The procedure of production flow analysis is consisting of the following steps. How the production flow analysis can be done, or method of grouping by this is one is data collection. The minimum data needed in the analysis are the part number and operation sequence, which is obtained from the process plans, isn't it? The data such as part number and operating sequence that we can get in routine sheets. Wherever operations are going on, that routine sheets is available, that from that we have to taken the data from that sheet. And after that, sorting sorting the process plans, that is part are segregated and arranged into groups according to a similar or identical routine, like that. right? And last is preparation of that production flow analysis chart. The process used for each group are then displayed in the FEA chart. That is, we see the chart is tabulation of the process or machine code number for all the parts of part families. This is what machine and this is what parts, right? In this tabulation, the entries are 111 and the indicates the part requiring in A to I. That is what the parts. So here, if you see the machine 1 has done on the part A. Similarly, machine 1 done on part D. Similarly, machine 1 and done on a part H. Similarly, machine 2 is done on the part E and part I. 3 is on part C and part E and part I. Fourth is on part B, part F and part no. Only two are there. And if fifth machine is on part A and part H and so on. So you have just noted the chart. Then if you see, we can sort them accordingly. That is what a clustering analysis. From the pattern of the data in the PFA production flow analysis chart, the related grouping are identified and rearranged into a new pattern that brings together groups with similar machine sequence. Are you getting this? So as we have seen here, suppose machine third CEI CEI and second is I, sorry, E and I. If you see here, third one is CEI, third one is CE and I, isn't it? And second is E and I. Whether you can put this here or this first. Actually, maximum where we get that we need to put in a grouping manner, so that we have done like this grouping manner where previous where the process are scattered over here. So now here what happened, it comes in a sequence, in a grouping similar machine sequences. So this is what kind of production flow analysis. If you see a benefits of uh, group technology, you can say here facilitates a formation of part families and machine cells, quick retrieval of designs, drawings and process plans, produces design duplication, faster duplication, provides reliable workpiece statics, and provides reliable workpiece statistics, facilitates accurate estimation of machine tool requirements and logical machine loading, permits the rotationalization of tooling setups, reduces setup time and reduce the production throughout the time throughput throughout time, allows the rotation sorry allows rationalization and improvement in tool design, that is scattered, that we have seen, that is scattered and make a group sequence. So on that help we can get the benefit of that group technology, and aids production planning and scheduling procedure also. It's one kind of benefits of group group technology, and it improves cost estimation and facilitates cost accounting procedures as well. Because of grouping, we easily estimate and facilitate the cost accounting for the similar kind of parts. If you make a sub group of them, so automatically it would be easy for accounting as well. And it provides for better machine tool utilization and better use of tool fixture and people satisfaction, and facility in NC part programming as well. So these are the some kind of some of benefits of group technology. So in next video we'll see the further content of group technology, or in a flexible manufacturing system, what are the next parameters and what are the next things to be studied. Thank you one and all.